A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hello everyone. I'm standing on Kapad Beach, a very important historic place located near Kozhikode. It was here in 1498 Vasco da Gama landed with his 170 men. We all know the famous voyage of Vasco da Gama. It was the winds and an unyielding will that helped this mariner to sail thousands of kilometers from Europe to find a sea route to India. The role of winds in that voyage, which changed the course of our land's history, is worthy of mention. So dear students, in this session we are going to discuss about winds. We also discuss how do they influence us, which are the different types of winds, their formation, effects and much more. But before talking about wind in detail, let me remind you something that you have already learned. We know that the atmospheric pressure is the weight of atmospheric air that pushing down on the earth. The average weight of that air exerts on the earth's surface is 1034 milligram per centimeter square. How do we know this? How do we measure atmospheric pressure? So, the atmospheric pressure is measured using an instrument called mercury barometer. This mercury barometer records atmospheric pressure in units like millibar and hectopascal. As you can see, this 76 centimeter indicates the level of mercury at a normal atmospheric pressure. And the atmospheric pressure at this point will be 1013.2 millibar, or you can say 1013.2 hectopascal. Now, I want to introduce you to the three factors that affect air pressure. Factors that cause variations in air pressure and the variations in atmospheric pressure are the basic reason for wind. There are three factors that affect air pressure. The first one is altitude or elevation. I'll explain this with an example. So, let's say that in order to see and understand different landscapes, some of you have decided to go on a field trip. You went to some different landscapes. Suppose Arjun decided to go down into a canyon and take a look at what was going on at the bottom. At the same time, Neetu decided she wanted to just sort of lay down on this flat plane over here and she is going to read a book. While the third one, Neena, as she was full of energy, she decided to climb up this mountain. So here is Neena. So each of these people is being exposed to a different amount of air pressure. The question is, who is under most pressure and who is under the least? Well, if we go back to our definition that atmospheric pressure is caused by the weight of the air above you, it becomes clear that Neena has the least amount of air above her because she is high up, so she got only a small amount of air pressure pushing down on her. Next is about Neetu. Neetu on the plane has all of this air above her and gravity is pulling it all down onto her. So she is under much more pressure than Neena. Arjun is standing farthest down, right? And he is under the most pressure. So the atmospheric pressure decreases with altitude. There is actually less air when you are at a higher altitude or higher elevation. The pressure decreases at the rate of 1 millibar per an altitude of 10 meters. As one goes up, there is decrease in atmospheric pressure due to the rarefication of air with altitude. This is why mountaineers carry oxygen cylinders with them. As you go down or as your altitude decreases, density and pressure will increase. You are under more pressure the lower you go. I hope you have now understood that altitude and atmospheric pressure are inversely proportional. Now let's move on to the second factor which affects atmospheric pressure, that is temperature. So, in the morning when the sun rises and the air warms up, Well, you hopefully remember that if the temperature increases, the molecules will expand and this will make the air less dense. And if it's less dense, it ascends. So, there will be less pressure. And the opposite is also true. If temperature decreases, molecules contract. So, density and air pressure increases. The ascending air spreads to the sides and starts cooling down. As it gets colder, the molecules are going to contract. They are going to move close to each other. So, the air becomes more dense. This dense cold air sinks, always sinks, which means it drops downwards towards the Earth's surface, creating high pressure. And it's because of this temperature element, the tropical region experience low atmospheric pressure compared to the colder regions. Let me explain how. As we all know, the surface of the Earth around the equator gets the greatest proportion of direct sunlight throughout the year. So, it always stays comparatively warm. That warm surface in turn warms the air near the surface and causes to rise. Air rising at the surface means low pressure at the surface. This is how the tropical regions experience low atmospheric pressure. So, that's all about temperature. Now comes the third factor. The third factor that affects air pressure is the humidity, or we can say the amount of water vapor in the air. First of all, let's see what humidity is. Here is the definition. Humidity refers to the quantity of water present in the atmosphere. So, if the quantity of water vapor is more in a unit volume of air, the atmospheric pressure will be less. But why? Because water vapor is lighter than air and hence it ascends. And that's why humidity and atmospheric pressure are inversely proportional. Now let's look at this image over here. These points A and B are two places having same elevation. Elevation means height. My question is, which of these has a low atmospheric pressure? So, I would say the place A must have a low atmospheric pressure. Why? Because A is a place which is close to the sea. As it is close to the sea, its atmosphere will have more quantity of water vapor than a place like B, which is far away from the sea. And like we said earlier, humidity and water vapor are inversely proportional. So, point A has low atmospheric pressure. Now, let's move on to another image. You see these lines over here. These lines are drawn by joining places having same atmospheric pressure. And these imaginary lines are called isobars. By analyzing the trend of isobar values, we can find out whether atmospheric pressure of an area is higher or lower than that of the surrounding places. If the atmospheric pressure of an area is higher than that of the surrounding regions, then it can be designated as high pressure. So, we can write high or H over here. Similarly, if the atmospheric pressure of an area is lower than that of the surrounding regions, just like here in this picture, then it can be designated as low pressure. We can write low or L over here. So, now we know what is air pressure and the three factors that affect air pressure. So, see you later.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.